Well, my name is Eric, and I'm with themoresuccessfulyou.com, and today I want to go over some common derivatives. Okay, so let's start with the trigonometric functions. So f of x equals sine of x, f prime of x equals cosine x, f of x equals cosine x, f prime of x equals minus sine of x. So you see, this is pretty easy to remember. It just goes in a circle, and then when you are at cosine, you get a minus sign. And then the derivative of minus sine will be minus cosine, and the derivative of minus cosine will be sine. Okay. And then, so then what is the derivative of tangent of x? So we can find that with the quotient rule. F of x equals tan x equals to sine x over cosine x. So what's the derivative of, what's f prime of x? It is low d high minus high d low over low low. Okay, so now let's plug in. So we have cosine x times cosine x minus sine x plus, because we're multiplying by a negative sign, over cosine x squared equals, so from trig we know that cosine squared times sine squared, or no, cosine squared plus sine squared equals to 1. So this is 1 over cosine squared, which is secant squared. Okay. And if we want to figure out what cosecant, secant, and cotangent, those derivatives, we can do this. It's very, very simple, very quick. F of x equals 1 over sine. This is cosecant. So low d high. So we have low times 0 minus high cosine x over sine squared x equals to, we have a minus cosine x divided by sine squared x equals, so then we'll have a minus cotangent x times cosecant x. So then this is cosecant x dx equals, okay, f of x equals 1 over cosine. So now we'll do secant. So f prime x equals low d high minus high d low. So that's equal to tangent x times secant x. And then finally, f of x equals to cosine over sine. Same thing as before over here. Well, f prime of x equals low d high minus high d low over low low equals, we have a minus 1 on top, and then we'll have sine squared on the bottom, which equals cosecant squared x. And that's the derivative of cotangent of x. Okay, so let's move on to some more common derivatives. Okay, so let's do the logarithm function. So if f of x equals ln of x, then f prime of x equals 1 over x. And that's just a rule. I have a very intuitive explanation for that. But the one thing that I would say is that if you look at the power rule, it's defined as long as n is greater than 0 or n is less than 0. So n not equal to 0. When f of x equals x to the n, as long as n is not 0, then this equation holds. Because if n is 0, then it's a constant function. So that's one note that we can't get confused here, is that this is the only function that has that as a derivative. Okay, so and then let's do the exponential. F of x equals e to the x, f prime of x equals e to the x. That is the only function that has the derivative equal to itself. And then let's go one step further. So in general, f of x equals ln f of x, or let's call that g of x. Then f prime of x equals 1 over g over x times g prime of x. So in this case up here, g of x equals x, the derivative of x is 1, and so we get 1 over x. And then if f of x equals if it's e of f of x, then that equals f prime of x e to the f of x. And we'll get into this in another video, but this is essentially the chain rule. What I'm trying to say here is that you have e to the x, but then you can really put anything in here and it'll be pretty much the same thing. Not to try and confuse anyone. But yeah, we'll do the chain rule. We'll do a chain rule in another video. Okay, I'm trying to think of any other common derivatives, and I don't think that I have many more that I did not cover. So if you found this video of use, please leave a comment and hit the like button. And please give me some tips and suggestions on what I can do better and what content that you would like to see. Thank you for watching, and have a great day.